Hey guys, we're going to be looking at polynomials. In front of you are vocabulary words you definitely want to look at if you're not already familiar with. Okay, but even if so, verify the definition, look at some examples in the glossary of that e-textbook I've made available to you guys on Schoology. Okay, with that said, we're going to look at some examples. Here it says identify the degree of the monomial. Alright, what you want to do is you simply want to look at, okay, the fact that this is one term, okay, there's no separation of plus via pluses or minuses. So when that's the case, okay, you want to look at this monomial here, okay, and that's the definition of a monomial, one term, and you want to take a look at the exponents and add them. Okay, so 3 plus 5 equals 8. So the degree of the monomial is 8. Alright. Let's see here. Let's go ahead and use this little symbol like that. Degree is 8. Alright. And that'll be kind of our own little language. So the degree equals 8. For the next practice problem, you really want to jot down this table. Now here I've got an example. It's your call as to whether you want to jot it down or not. But everything here and here is important, and maybe a good name for this table. Classify polynomials by degree is important. So if the degree, like we just looked at, is a 0, it's constant, so on and so forth. Linear is 1, you guys know. Quadratic 2, cubic 3, quartic 4, and quintic 5. Alright? And if you're a little iffy, here's some examples again. It's your call whether you jot those down. You can pause the video. Alright, it says rewrite the polynomial in standard form, then identify the leading coefficient, degree, and number of terms. Name the polynomial. So let's go ahead and do that. Alright, so to write in standard form, all you really do is list all the terms from greatest to least exponent. Alright, so if I look at this, I can tell 5 is the highest degree, so I've got. Okay, and what I can do is I'll scratch it off so I don't get confused. Then here is this one. Scratch it off. Next is 3. Next is this. Alright. Now if there was, let's say, no x, I could simply put it plus 0x. But in this case I do have an x term. Okay, so minus 5x, and then finally, whoops, I forgot to scratch here. And then plus 6. So there is my polynomial in standard form. Then identify the leading coefficient. Alright, so here, alright, here's the leading term. And simply because he's up in front with the highest exponent, okay? So in terms of leading coefficient, we have the -7. Remember, the coefficient is the number in front of the variable, so it's -7. The degree, in this case, is what? 5. Alright, notice that in the last problem, these x's would have been multiplied. Here they're separated with pluses and minuses, so that separates terms. Okay, so this term in particular, or this polynomial has one term with the highest degree being 5. Okay, and the number of terms, let's just count them: 1, 2, 3, 4, 5, 5, 6. Okay, so terms, we have 6. Alright, so when you have one term, that's a monomial, 2 of them binomial, 3 is a trinomial, and anything beyond that is just a polynomial in general. Okay, so in this case we would have a what? Alright, we'd have a quintic. Alright, so based off of the degree, alright, is this first portion. Okay, the name. Quintic. Alright, make sure I spelled it right. Quintic. Okay, so the degree gives you that first part of the name. Then the last name refers to the number of terms. Here we have 6, so we'll just call it a quintic polynomial. You can get more precise than that, but that'll be sufficient. So again, if it's one term, it must be monomial. If it's two terms, binomial. 3, trinomial. And beyond that, you're safe just calling everything else a polynomial. Alright? Okay. Write your answer in standard form. Remember, standard form, we've just looked at it. You want to have the highest exponent listed first and then in decreasing order. So to add these, what you want to do is kind of organize each unit. Okay, so let's go ahead and kind of rewrite this vertically. Okay, here's a suggestion. It makes the math a lot neater, cleaner, and it helps kind of avoid mistakes. So I'm going to line up, right, the common term. So this was a d to the 5th. Okay, next I have a plus 6d to the 3rd. Okay, so it's kind of lined up. I wish this one was lined up a little better, so we're going to do that here. Plus 6d to the 3rd, so they're lined up, and then minus 4. Alright. Parentheses, no parentheses. Again, the big thing here is, can you line up the like terms? If you do, it makes your life easier, so then all I do is just add down. Nobody there. Here I have essentially a minus 1 plus 6, so I've got 5 d cubed, and then here I know I'm going to have a d to the 5th. Okay, so now I just take the 4 plus this invisible 1 here, and I've got a 5. Alright, they wanted in standard form, so I need to check that my exponents are from largest to smallest in that decreasing order. Okay, so 5, 3, and I'm safe. Alright. Next, graph the polynomial function. On a graphing calculator, describe and identify the number of real zeros. Alright, let's see if we've got the calculator up and running. Alright, so here we're going to go and insert that polynomial. Hit enter, and there's what we're looking at. Okay, now going back to the question. Alright, it says describe the graph and identify the number of real zeros. So let's do that. Alright, let's see here. I'm going to take an image of this here. Alright, so there's a lot of things we can say, but let's just kind of cut to the chase. Describe the graph. One thing you want to notice that this graph is increasing, and then there's a change here. So 1, then it goes, right, it went from down to up. So that's, right, after it went up, there was 1 change. Then it went down, 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 then it started going up. So there's a second change. Then after it went up again, it went down again. So there's 1, 2, 3 changes, okay? We'll use this triangle, 3 changes in terms of increase and decrease. Okay, this is an abbreviation, so increase, decrease, 3 changes. Alright, and we'll leave it at that. Okay, that's pretty significant. And then the other significant component to this description is it says identify the number of real zeros. Well, real zeros, unlike imaginary zeros, alright, are roots or x-intercepts, okay, or zeros of the function. So here we have 1, 2, right? Crosses the x-axis 1 and 2. Notice this, nothing else on the graph intersects the x-axis, so we have 2 real zeros. Okay, we'll use this r with a double back to kind of abbreviate. Okay, so 2 real zeros. All right. And lastly, we have this kind of problem. So this is pretty beneficial for you guys moving forward into pre-cal and things like that. So here you have just some function h of x and another one k of x, and they want you to kind of perform some algebra with that. All right. So here's what you want to do. You kind of want to rewrite this, right? It says find this. So you got to be like, well, how do we find that? Typically, substitution is one route to go, and that's the route to go here. So h of x, I'm going to substitute it with that right there. Okay, this polynomial, 6x minus 9. Alright, so where were we at? So we've got h of x substituted in. Now here, notice what I need to do. This 2's different. It didn't come with it, so I'm going to put minus 2. I'm going to use a bracket to really announce, hey, this 2 should be distributed later. Okay, I've got 3x squared minus 8x plus 8. Alright, and I'm going to go ahead and distribute this bad boy for a little bit. Okay, 2x squared minus 6x minus 9, because I want to see what he does to everybody. Alright, so I got a minus 6x squared. This minus with this minus gives me a plus 16x. And this minus with this plus gives me a minus 16. Alright, now all I really got is a whole bunch of terms that I've got to combine. Alright, where were we? So we're going to now, that we have all these terms, just kind of organize them. Alright, so if you like that approach, I do that whole vertical addition process. Let's go and do that here. Okay. Or better yet, since they're already kind of simple to look at, let's do it this way. Let's do it horizontally so you can look at both approaches, kind of determine what works better for you guys. So I'm going to look for the highest exponent, which is a square. All right. So I'm going to take him with him. So 2 minus 6 is negative 4x squared. Okay, so that means I can cancel him out and him out. Used. Okay. The next exponent down would be the x to the first power. So I've got negative 6 and a plus 16. So that's going to give me a plus 10x. So I've used him up with him. And lastly, I got a minus 9 with a minus 16. That's minus 25. Done and done. Guys, thanks for your time. Can't wait to see you in class. If you have questions, please ask tomorrow.